Welcome back to the podcast. In this episode, Donahue and Charley Huang from NVIDIA will debate the increasing demands being seen on GPUs from the most unexpected workloads. Are GPUs still reserved only for the 3D CAD CAM operators and a luxury for the knowledge worker? You may be surprised with the answers to these questions and more. Let's join the conversation.
All right. Welcome, everybody, back to the podcast. My name is Sean Donahue, and I have broken into the podcast studios, and I've pirated the microphone away from Angelo again, and we're going to do a special broadcast. Today, we're nerding out on GPU and vGPU, and that's why I'm so excited to have my guest from NVIDIA, the one, the only, the graphically, Charley Huang. Charley, welcome.
Thank you. Thanks for having me. So excited to be here today and nerd out on vGPUs and GPUs and VDI. Great to be here.
Oh, for sure. And I, like I said, I share the sentiment, the emotion with you because it is very exciting. Love the GPU, love graphics and what they do for us. And I've been a longtime fan, a longtime listener, first-time caller for NVIDIA, going back to, the early days of GTC, back when they held it in, I think it was San Jose, at like a Hilton or something. It was very exciting back then, but it's only gotten more exciting lately. But Charley, how long have you been with NVIDIA?
I've been at NVIDIA for over 4 years. I mean, it hasn't been too long, but it feels like a long time because the company's just kind of evolved and grown so fast. So it's been an exciting place to be.
And if I'm not mistaken, it goes back to in some of the early origins of NVIDIA was it in gaming? Am I remembering that correctly?
Yeah, kind of started out as a gaming, a graphics company, and it's really evolved beyond that. Gaming's still a very important and growing part of the business, but enterprise has been growing very quickly as well. And there's a lot of exciting stuff around professional visualization and artificial intelligence that just kind of goes across all industries and enterprises.
Yeah. I was just talking right before we lit up the microphones here. We were talking about AI and ML, and that is definitely something I want to get into. So maybe if I don't screw this up royally, I can actually ask you back on a later episode to talk about AI and ML in more depth. But today is all about the GPU. And like you said, the evolution of it and really it breaking into mainstream corporate America. And I was kind of curious, Charley, what you've seen from your seat. What are you seeing as far as the market growth and demand in vGPU?
Yeah, for vGPU, we started this. Not sure when I start. Over 4 years ago, it was already gaining a lot of momentum, and every year there's just more and more demand for it. Especially coming out of the pandemic, that's really changed things, right? And so enterprises are investing in what's called a digital transformation, right? And VDI and user computing, it's huge now with everyone more in a hybrid work model. I mean, for us here, both of us, for example, we're working from home, right? That's kind of the norm. And then going into the office, it's kind of a part of it, but it's sort of optional. So it's not where everyone went into work every day like before. Now it's kind of a mix of both, right? And then also with some traveling opening up. So people want to have their compute wherever they are, right? Yeah. And that market, it's expected to grow to $20 billion by 2030. And then, another stat that I've seen is, 40% of storage and compute will be as a service, and some of these top challenges that the enterprises are facing as we're they're going through this digital transformation is user experience and security. Those are huge with people in different places rather than one central location. So this is an area that continues to grow and becomes more and more important.
And I don't, we're going to have to delete that out because I don't like my family to know I work from home. I kind of hide up here in the home office. They don't know where I am. And then, I kind of appear later. So, but
really?
No, I'm just kidding. But you're right. The vGPU, I mean, I go back on the vGPU side of the house back when, NVIDIA and Citrix were, really specializing it and optimizing it, I should say, on Zen server. And to see where it's evolved and the adoption that it's gone through since those days, and really, the thing that I was struggling with back then was just the use of a GPU. And I like how we used to describe it back then, but I would love for you, just as a level set for everybody who's listening out there today, to kind of wrap their head around what do we mean when we say vGPU, versus, of course, GPU. But we used to describe it as like slicing and dicing the GPU across multiple virtual desktop sessions on one underlying appliance. So one GPU, one physical GPU being able to be sliced and shared across multiple users of a running shared desktop. So how would you describe it, Charlie?
Yeah, so the investment on GPUs, you have one GPU and it has so much compute power, right? For graphics and AI. So much more power than, let's say, a single user may need. And, enterprises want to maximize their return on investment in these GPUs. And so with vGPU, you could fractionalize the GPU. So you could put multiple VMs, multiple users on it, right? And just get huge benefit out of just that one single GPU for many people. And so you could have, you and I could be taking advantage of great graphics performance on the same GPU, and we wouldn't even know that we're sharing. But we would say, hey, this is great. But in the end, so it's great for us as end users. It's great for IT, right?
And it's not as if we're butting into each other and, hey, you get your hands off my GPU and get your chocolate out of my peanut butter, or get your peanut butter out of my chocolate. It's the best of both worlds because we can fractionalize, like you said, that GPU. But more important than that, now I remember back to a demo I gave, and, it was a healthcare demo, and it was running a virtual desktop on a Chromebook, which did not have a lot of power to it. It was, I literally stopped off at a Best Buy on my way to do the demo, bought the Chromebook, launched a virtual desktop session, and I was able to spin and rotate and manipulate a 3D model of a heart from that Chromebook device. And it was all thanks to the virtual desktop running on the back end, but also running that underlying infrastructure with that vGPU. But our use of GPU today, and this is really where I wanted to go with this, it's not just for those specialized use cases. It's not just for the 3D models or the CAD CAM operators. It's really, GPU is opened up to a lot more uses. And I'm curious as to if you're seeing that, or am I just making stuff up?
Yeah, I mean, I'm exactly what you described. I'm not like a graphical power user at all. I mean, what I use is Office, Microsoft Office, or the Google G Suite, and it could be like Teams or Zoom. We use a lot of, and just the video conferencing is driving up just a lot of need itself for, graphics performance, right? When as we're talking, and when I see you on video, I like to see you clearly, right? Otherwise, why turn on the video? So, things keep pushing up. It used to be just regular HD, then it's full HD. Now we have 4K, right? So this is the kind of things that we're talking about. It's nothing where it's out of the ordinary. It's all these common things, right? And then here's another one. I use Chrome, and I don't know how many tabs you have open. I have at least like 30 in any given time. I'm online. I have like 30, maybe 50 tabs open. And yesterday it was all about bookmarking pages. Now it's about leaving the tab open so that you could go back to it, Right. And that takes so much compute power. So when you think about, a CPU, it's kind of general purpose. If you're trying to make it do everything, it won't be very good at one thing, right? So let a GPU do the work of the graphics part that it's really good at, right? And if you think about when you're on your VDI, you're pretty much looking at something, right? Anything that you're looking at is going to require graphics. And just
because it's a screen scrape of a virtual machine happening in the server, or
and just
on the back end.
And just to give you some put some numbers to it, right? If you look at the CPU usage in 2019, teams used about 3% of the CPU in one session, right? If you look at not even today, just like in 1 year, in 2020, we're seeing it uses 78% of the CPU, right?
Wait a minute! Whoa!
Yeah, it's incredible.
Teams at 19 was using 3% of the CPU capacity. And a year later, Teams 20 is using, what did you say?
78%. And this
78.
And this is a study done by Lakeside. Not making these numbers up. And this is real usage. And this is something that you and I and, all the enterprises use every day, right? And it's not just video conferencing or browsing, it's the OS as well. If you look at Windows, just kind of the progression of it becomes nicer and nicer to use. I don't have the stats in front of me, but I don't know if you use Windows, but, when I upgrade to Windows 11, they've done a fantastic job with the user interface. It looks beautiful, like everything that they have. And that continues to use more and more graphics to provide that better user experience, right? As they continue to evolve the OS.
But I could instead, because you're right, Windows 11, Windows 10, Windows 11 really, and that's what I want to talk about as well, is how hungry for the GPU these apps and even the operating system are. So I guess if you don't want to run Windows 95, you're going to have to deal with this and confront this GPU hungry operating systems that we have. And it used to be Windows was getting more and more memory hungry, was getting more and more CPU hungry. But am I mistaken? Am I making it up that when you launch some apps, let's say it's Office productivity apps, let's say it's a Chrome browser, or like you said, maybe Teams or Zoom or any UCS, do they actually go looking for a GPU first?
It can, but typically when you're launching an application, it's going to launch the application. It's going to look at look for the CPU resources to launch the app, right? It's not until it needs to start rendering graphics that it'll go look to see if there's a GPU in which it could do the graphics compute on, right? So for example, I talked about Office productivity and Microsoft Office. Excel by and large is going to use the CPU. But again, if you're using the CPU for everything like graphics, then it's just going to bog everything down, right? If you can offload the graphics stuff to the GPU. So for example, inevitably, if you're looking at any web page, there's going to be some images or maybe embedded videos, right? I mean, this is aside from, you maybe wanting to, watch YouTube or check your Facebook, Instagram, or TikTok feed, right?
Right.
Those will inevitably have some graphics or video that if, let's say you have Excel running, taking up, let's say 63% of the CPU utilization, then it's going to bog down some of the other things and ultimately reduce the user experience, right? How fun it is to have everything slow and you're just waiting for things, right?
Right. It's crazy to think of. It's so amazing today if you look at that evolution. And in a virtual desktop environment, it's even more exacerbated because we've got the latency or the traffic that we have to span across our network. And then if you think of the rendering that's going to have to take place on the virtual desktop using a GPU or even a CPU, it's just whatever you can do to optimize and make that user experience better, because nobody wants to have a lousy user experience. And then the employees start complaining, filing tickets, and they inevitably say, my Citrix, my virtual desktop, blank. So it is crazy to think of. But I want to point out some stats that I recently heard and just get your first impression on them. There was some testing that happened somewhat recently, and my understanding is, correct me where I'm wrong, using the NVIDIA N-Vector benchmarking tool. The testing saw that a single A16 GPU could support 64 virtual desktops, and each one of those had 2 vCPUs and a gig frame buffer for the profiles per node. Now, I mean, that just sounds amazing to me, but then, and you don't usually see this type of scalability, but if you were looking at 2 A16 cards that had been installed, it went up to 128 scalable sessions. What's your experience or thoughts on that?
Yeah, no, that was a great test that I saw. I think Lee Caswell, right, from the Nutanix side, published a blog. And I invite everyone, all our listeners, to go check it out, because it's some fantastic tests that were run. And 30% improvement in frames per second, 1/20th of a second for latency. I mean, that's just incredible. Can you imagine doing your work on a laggy system where there's a delay anytime you move the mouse or like type? You type something and you wait like a second till it shows up on the screen. And you have to deal with that kind of experience for 8 hours plus a day, 5 days a week. Oh, right. Boy, I need a vacation right away. I mean, you have to be very patient if you're gonna, sit through that kind of experience. And so
I don't think I have to imagine it. I remember it back dragging. Do you remember dragging a window across your Windows operating system, of course, and just the black smear that would follow because it couldn't keep up with rendering the graphics. And those were that happened in virtual desktop environments all the time as well. And that delay between typing in something on your keyboard. And for me, I have to look at the keyboard when I type. I don't know what's going on the screen. So it was massive pain in the butt.
And what do you do to solve that? You just type slower, or you move your mouse a lot slower, right?
Right.
And you mentioned the Chromebook demo that you gave just earlier, right? It's funny you mentioned that, because I'm a big Chromebook advocate. I love using Chromebooks, and one of actually my favorite Chromebooks. It's kind of a lower end Chromebook with like a low end ARM CPU. There's no way I could do my work on that, and so I log on to my GPU accelerated VDI. Man, it's just like I'm on like a gaming rig or something. It's incredible. You connect it to an external monitor. You would never guess that Chromebook costs like $150. I kid you not.
Right.
And my primary setup is I'm running 3 WQHD external monitors on a first generation Mac Mini M1 ARM GPU. I mean, this is a low end desktop, mini desktop I got for maybe like $550, but it's running 3 monitors like a champion, literally as if I had like a $3,000, $4,000, $5,000 workstation underneath my desk.
And how old is that device? Because that's the other benefit.
It's whenever the M1 chip came out, must have been at least 2 years ago or something like that.
Yeah.
Yeah.
So that's another beautiful use case here, again, tying all of this stuff together with that, underpinning hardware and hyper-converged and, the virtual desktops, as well as the vGPUs being able to extend the life of those devices. We haven't even touched on that, but no longer are we looking at a 3-year hardware refresh cycle. We can get easy 5 or even more years out of them.
Well, in a lot of these cases too, they have these bring your own device policies, right? So I don't just use, I mentioned Chromebook, but I have, an IT device. I do stuff on my phone these days and even tablet, right? So I'm running things on Android, on Chrome OS, on Mac OS, on Windows PC. So it's a hybrid workplace, but work from anywhere, anytime kind of environment, right? And this is what a GPU accelerated VDI enables workers to do.
And you know what? I know we're our backs against the wall on time here, but I can't let you go without telling you that I just did a webinar. It was a weird one. I had an NFL coach. If you're a fan of the NFL, listening in, I had a guest on, Coach Dave Wannstedt, who coached the Bears. He coached the Dolphins. He's such an impressive career. He has nothing to do with what I'm about to tell you. I'm just name dropping, I guess. But one of the case studies that I referenced for our listeners was a Cal State in Long Beach. And I love this use case because it is pandemic driven, but that's a milestone event for us, which opened up the idea of remote and new learning models for their students. But even after the pandemic, you may remember what it was like waiting in the lines or signing the sign-up sheet to get computer lab time. And if you think of students who work with CAD, AutoCAD or CAD/CAM applications, they need, heavy, like we've been talking about, heavy duty compute power. And so there's always traditionally a long line, a long wait to get onto those specialized systems. Well, Cal State Long Beach actually deployed Nutanix for EUC, Citrix for VDI. I'm going to have to double check that one, but with NVIDIA GPUs. And now the students, like we've been saying, they actually didn't have to sign up for lab time anymore. They launched the virtual desktop that was GPU enabled. They sliced and diced the GPU, and they were able to do those CAD, AutoCAD projects anywhere, dorm room, coffee shop, didn't matter. Who knows? Frat house during a party. Who knows where they were doing it? It just didn't matter because it was the same experience that they had when they waited their turn for the computer lab. Such a great, great case study. That, by the way, is available on the Nutanix website. If you look for Cal State University, Long Beach, you'll find that case study. But Charlie, I cannot get away with addressing you and not use my Boston accent. Charlie, this has been an awesome conversation. I love nerding out on GPU. I want to get you back on the AI ML stuff, though. on another one. But let me ask you this. Now that we've got listeners out there, they're fanning out over Charley and they want to get more about NVIDIA GPUs, Nutanix EUC, HCI, and virtual desktops. Where do you think we should send them?
We have a number of resources. I'm not sure if there's any place that you could post the links, Sean. There's a number of blogs that we wrote together. I'd say start with NVIDIA.com and go to the virtualization page to check that out.
Absolutely.
Or just do a search on NVIDIA vGPU and Nutanix, and you'll see a bunch of great resources and the things that we've done together.
Yeah, and I think we're going to make it easier for our listeners. We'll hyperlink into the buffer, the abstract for the podcast, and we're going to link people out to, of course, the NVIDIA landing page, Nutanix's landing page that has the NVIDIA tech partner, focus on it, as well as I encourage you to jump over to the Nutanix.com/blog site and take a look at what the testing results are. The author of the blog's name is Lee Caswell. So not only is he my skip level manager, great guy, very smart, wicked smart, as we say in Boston, and get that blog. It is, like I said, Nutanix.com/blog, and you'll be able to find it there. But Charley, it has been awesome. I love what's going on with GPU and where we're going. But this is my ending question for you, Charley. If you were to look in your crystal ball 3 years down the road, where do you see the growth and demand of vGPU with virtual desktops on a Nutanix hyperconverged?
Yeah, so I'd say kind of expanding with virtual desktops and even virtual workstations kind of at the higher end. Some of the trends that are kind of driving more graphics in that space are things like collaboration platforms, right? So NVIDIA has a collaboration platform called Omniverse, and this is essentially a solution for the metaverse, right? You hear a lot about the metaverse. That's all graphics, right? And so that's going to drive a lot of it. A lot of the XR, right? NVIDIA has a solution called Cloud XR, streaming, augmented reality, and virtual reality. That's going to become very big as well. So you'll see that really starting to pop up now and over the next 3 years, I'd say. So, as we talk about just kind of these everyday things that we do, everyday apps that we use, it's just going to get magnified as we get more into, the metaverse and augmented and virtual reality.
Cool. That sounds awesome. And for the number nerds out there, the testing that we referenced in our earlier conversation was actually running on a Nutanix NX3155 G8, just in case you were keeping score of that. But Charley, I'm going to look for you in the metaverse and hopefully hook up with you there. But until then, we're going to have to say goodbye to everybody. And again, thanks, Angelo, for letting me break into the studio here today. But we'll catch you all next time, everybody. Bye-bye.
Thanks, Sean.
Thanks, Sean and Charley. I'm looking forward to the next conversation. To learn more, check out the show notes with links to resources at next.nutanix.com. With that, from your friends here at Nutanix, have a great week.